Hello everyone, myself Anugraha Ganesh TG from 2nd MSc Physics, Hindustan College of Arts and Science, Coimbatore. Today we are going to discuss about the topics simple cubic structure, body-centered cubic structure, face-centered cubic structure and hexagonal close-packed structure. So let's see what is simple cubic structure. Here two figures are given showing the atomic site model and hard sphere model. So here we are going to discuss about the number of atoms per unit cell, atomic radius of the structure and coordination number, packing factor of simple cubic structure. To find the number of atoms per unit cell, we have to know the speciality of the structure. In this structure, there are 8 atoms at the 8 corner of the cell. Each corner atom is shared by 8 unit cells that adjoin at each corner. The share of each corner atom to a unit cell is 1 by 8 of an atom. So to find the total number of atoms per unit cell, we can substitute the values, which is equal to 8 into 1 by 8 equal to 1. Next, let's see how to find the radius, atomic radius. What is atomic radius of simple cubic structure? In a simple cubic structure cell, the atoms are in contact along the edges of the cube. Here A is taken as the length of side of cubic cell. The atoms touch along the cube edge. To find the radius, 2r is equal to a. So we can easily find r equal to a by 2. Next, what is coordination number and what is the coordination number of simple cubic structure? Each corner atom touches 4 atoms in its horizontal plane and the 2 atoms, one vertically above it and one vertically below it. So there are 6 equally spaced nearest neighbor atoms, each at a distance a from that atom. Therefore, the coordination number is calculated to be 6. Next, let's see what is packing factor. Packing factor is known as the volume of all atoms in the unit cell divided by the volume of unit cell. So, we can find the volume of all atoms in the unit cell by multiplying number of atoms in the unit cell and volume of one atom. So we get 1 into 4 by 3 pi r cube divided by a cube. Here a is taken as 2r. So we get the value pi by 6, which is equal to 0.52. So packing factor is equal to 52%. From this packing factor and finding the coordination number, atomic radius and number of atoms per unit cell, we can say that simple cubic structure is a loosely packed structure. Polonium is the only element which exhibits this structure. Next, let's see what is body-centered cubic structure. Here also the two diagrams of atomic site model and hard sphere model is given of body-centered cubic structure. To find the number of atoms per unit cell, the same theory of the simple cubic structure is followed here also. There are 8 atoms at the 8 corners, each shared by 8 unit cells and 1 atom at the body center. The atom at the center of the body of the cell wholly belongs to unit cell. So the total number of atoms is equal to 8 into 1 by 8 plus 1. So 2 is the total number of atoms per unit cell. To find the atomic radius, the length of the body diagonal equal to 4r. So let's substitute the value like 4r square is equal to 3a square. Here r is the atomic radius, which is equal to root 3 divided by 4 into a, where lattice constant a is taken as 4 divided by root 3 into r. The coordination number of body-centered cubic structure is taken as 8. The unit cell contains 1 atom at each of the 8 corners of the unit cell and 1 atom at the body center. The nearest atom to the corner atom is a body-centered atom and not the other corner atoms. The number of nearest neighbor is 8. So the coordination number equal to 8. Here also the packing factor is found. The same formula is used and the packing factor is calculated to be root 3 into pi divided by 8, which is equal to 0.68. So in percentage we can say it is 68% packing factor, and by knowing the packing factor as 68%, coordination number as 8, atomic radius as root 3 divided by 4 into a, and the total number of atoms per unit cell equal to 2, we can conclude that the body-centered cubic structure is not a closely packed structure. Tungsten, sodium ion have this type of structure. Next, let's see what is face-centered cubic structure. Here also the atomic site model and hard sphere model structures are given, and the face-centered cubic structure is non-primitive cell. It has 6 atoms at the center of the 6 faces and 8 atoms at the 8 corners of the cube. To find the total number of atoms, the equation is equal to 1 by 8 plus 8 plus 1 by 2 into 6, which is equal to 1 plus 3 equal to 4. To find the atomic radius, let's see the length of the face diagonal AF is equal to 4r. So 4r is equal to root 2 into A. Here r equal to A divided by 2 root 2. And the lattice constant A can be found as A is equal to root 2r. The coordination number of the face-centered cubic structure is taken as 12. As coordination number is defined as the number of nearest neighbors surrounding an atom. Here there are 12 atoms present. Next, we have to find the packing factor of the structure. So let us consider a HCP unit cell with lattice parameters A, C and atomic radius r. So the volume of HCP is taken as V is equal to 3 root 2 divided by 2 into A square into C. Volume of single atom is taken as V is equal to 4 by 3 into pi r cube. Therefore, the packing factor is equal to root 3 pi divided by 6 A square divided by C. For ideal HCP structure, C by A is equal to root 8 by 3. Therefore, the packing factor equal to pi by 3 root 2 equal to 0.74. While we convert it into percentage, we get 74% of packing factor for face-centered cubic structure. Next, we are going to discuss about the hexagonal closed packed structure. The coordination number is calculated as 12. It consists of 6 atoms, 3 atoms in the basal plane A and 3 atoms in the upper and lower planes B. Nearest neighbors are each atoms in the HCP structures have 12 nearest neighbors. Okay. Therefore, theoretically a sphere can touch simultaneously 12 identical spheres at the maximum in a 3-dimensional structure. Thus, an FCC cell has a maximum value for the coordination number. And the packing factor is calculated to be 0.74, similar to face-centered cubic structure. So I hope everyone is clear about the simple cubic structure, body-centered cubic structure, face-centered cubic structure and hexagonal close packed structure. Thank you.